Hello everyone, welcome back to Advanced Algebra 2. Today we're going to talk about 5-5 function operations. And in your workbook you'll find these notes start on page 252. So we're going to be just doing something called function operations, which means we'll take a function and we will combine them through addition and subtraction. That's what they mean by combine. So we'll add and subtract functions, we'll multiply functions, we'll divide functions, and we'll also do something called compose function, which means you put functions together that are separate. So you take functions, put them together, make them as one. Now, one thing that students need to be very, very aware of is what this notation means and how you say it out loud. The way that I say this out loud is I would say f of x. And so what this means is that it is a function of x. So f is a function of x. And what that means is f is a function of x. So let me give you a formula. Like 3x squared minus 14x plus 2. So what f of x means, it's just the name. It means we're going to call this function f, but the variable that you will see are x's. So it means f is a function in terms of x. So the formula is written so that there's x's, not another letter. G of x, 5x plus 2, means that the name of the formula is g, but it's in terms of x so that you see x's in the formula. So we can call a function whatever letter we want to call it. I could say h of x would be 5x minus 11. I don't even have to use x. I could use like v of t. That would mean my formula is named v, but when I write the formula, you'll see t as my variable. So like 5t squared. I like 5 today. 5t squared plus 17t minus 12. So that's what that notation means. And again, you see it f of x. It does not mean f times x. It does not mean that. I know they're written close together. It looks like you would think that's what that means, but it's not. It does not mean f times x. It means that it's a function. Its name is f, and then the variable that you see is x. All right, so here's some more notation that you need to be aware of. Like I said, today we are going to be adding and subtracting functions, multiplying and dividing functions, and also composing. So these, what you see below, are notations for each of those. Let me grab a highlighter here. There we go. Okay, so this first notation, f plus g of x, means the exact same thing as f of x plus g of x. It's just another way to write it. So that means take the function f and combine it with the function g. Works the same if you're talking about subtracting. F minus g of x means the same thing as taking the f function and subtracting the g function. They're just different ways of writing it. You need to be familiar with both because we use them interchangeably, and you need to be able to do one or the other. Here is what multiplication notation looks like. F times g of x means the same thing as taking f and multiplying it by g. For division, f divided by g of x means the same thing as taking f and dividing it by g. We'll get to composition later, but just so you know, these mean the same thing. So we're going to start with adding and subtracting. So if you look at example 1, we're given two functions. F of x equals 2x squared plus 7x minus 1, and g of x equals 3 minus 2x, and they want us to identify rules for the following functions. What that means is come up with a formula. Rules, that means formula. Okay, so they want me to find f plus g. So one way to write it is f plus g. Another way to write it is f plus g of x. Or you might also see them ask you to find f of x plus g of x. It all means the same thing. What that means, take the f function, add it to g. So let's do f of x plus g of x. Just substitute it in, add like terms. So the f function, actually let me color code this. Let's make g in red. So the f function is 2x squared plus 7x minus 1. That's going to be added to the function 3x, not 3x, 3 minus 2x. And I'll even put parentheses around f so you can see what's f and what's g. All right, pay attention, there's a plus sign in between, so I'm going to just combine like terms. So 2x squared, there's no other x squareds to combine it with, so this equals 2x squared. 7x plus negative 2x is positive 5x. And then negative 1 plus 3 is plus 2. So 2x squared plus 5x plus 2. Done. Then in part B, they want me to take the f function and they want me to subtract the g function. So I'll just follow my formulas. F is 2x squared plus 7x minus 1. I'm going to subtract the g function, 3 minus 2x. Now because I'm subtracting, this negative does get distributed to both, so it might be worth your time to distribute that negative so you don't make any sign errors. So that means I'll have 2x squared plus 7x minus 1 minus 3 plus 2x. Then I'll look for like terms. 2x squared doesn't have any other like terms, so 2x squared. 7x plus 2x is plus 9x, and negative 1 minus 3 is negative 4. So there we go. Moving on to example 2. In example 2, we're asked to multiply, but we have a word problem. So we're going to learn how to multiply in terms in context. All right, so it says suppose demand for a company's product at cost is X, or X. Let me start over. Suppose demand D for a company's product at cost X is predicted by the function d of x equals negative 0.25x squared plus 1,000. And the price P that the company can charge for the product is given by P of x equals x plus 16. Find the company's revenue. So they gave me a couple things in the problem. They gave me the demand. The demand is this function. That's demand. Then they gave me the price. Price they gave me by this function. And they asked me for the revenue function. Well, here I have the formula that revenue is equal to price times demand. So I need to set up a formula. I need to set up an equation here. So revenue, will let revenue be R of x. Revenue in terms of x. So R of x equals the price function, which is P of x, times, now I need to be careful when I draw my times. You need to be careful. Be careful. For times, draw a closed dot, because if it's open, it means something else. So closed. P of x times d of x. And then I'll substitute everything in. So R of x equals the P of x function, which is x plus 16, times the d of x function, negative 0.25 x squared, plus 1,000. And then all I have to do from here is distribute and multiply. So x times negative 0.25x squared is negative 0.25x cubed. 1,000 times x is plus 1,000x. 16 times negative 0.25, I believe is negative 4, but I'm double checking. Yes, minus 4x squared. And then 16 times 1,000 is plus 16,000. There's no like terms, so this is my revenue function. So adding, subtracting, multiply feel very similar to what you've done in the past. You just have to watch out for the notation. So just know this means to add the two functions together. This means to subtract. So when you're adding or subtracting, you just combine like terms. When you multiply, you're going to distribute. Dividing, let's look at dividing. Example 3. Okay, so now we're going to write a rule and domain for division. Okay, so now they say write a rule and domain for f over g. That means the f function divided by the g function for each pair of functions. So let's make the f function blue. Let's make the g function red. And I'm going to say f of x divided by g of x equals f of x is x squared minus 3x minus 18 over g of x, which is x plus 3. Now, I know before the break we did some long division, we did synthetic division. We could do that here, but I'll go ahead and give you a preview of what we're going to do in a couple chapters, and that's we're going to reduce this fraction by factoring. So the way that you do this, you're just going to factor the numerator and denominator. So start off by factoring the numerator and denominator as much as you can. So let's see, the numerator, x. Let's see, I can do a 6 and a 3. Make the 6 negative and the 3 positive. Let me just double check. Negative 6 times 3 is negative 18. Negative 6x plus 3x gives me negative 3x. Okay. Factoring. The denominator doesn't really factor. Okay, so factor the numerator and denominator. Then you're going to divide out common factors. So I have an x plus 3 over an x plus 3. As long as there's only multiplication happening, I can divide those out. So x plus 3 divided by x plus 3 is 1. Like 5 divided by 5 equals 1. Anything divided by itself is always 1. So x plus 3 divided by x plus 3 is 1. So f of x divided by g of x simplifies to just be x minus 6. So that is the simplified quotient. Check. Identify the rule. Done. The domain. With the domain, you do have to be careful here because the domain, yes, I could graph this and see what the graph looks like and go from there. However, you have to also check the domain for the top function as well. And whenever you look at the graph you won't be able to see everything at all. So you have to check the domain algebraically. And so domain are all the possible values of x that cause, like domain, all the numbers that x could be that give me a real number. So whatever I could substitute in for x and get out a real number for this expression, that would be what x is. What the domain can't be is a number that's going to cause my expression to be undefined. So what is the only number that we cannot divide by? 0. All right, so keep that in mind. We cannot divide by 0. Because we get an undefined expression if we do. So you can't divide by 0. So if I have this original expression at the top, what number for x would cause me to divide by 0. Like what number would x be in order to make the denominator be 0? -3. Here's how I figure that out. If you say, okay, well, we can't divide by 0. So if we can't divide by 0, then the denominator is not allowed to be 0. And then solve that. So x is not allowed to be -3. So for our domain can be anything, all real numbers, except x equals -3. Because at x equals -3, it causes my original expression to divide by 0. Even though that x plus 3 got canceled out, in pre-cal you'll see what, and actually in a couple of chapters in this class, you'll see what that looks like on a graph. Even though we canceled it out or divided it out, it still caused me to divide by 0 at some point in the problem. So our domain will just say all real numbers except for x equals -3. So to find the domain for these, let's summarize that up. To find the domain, you're going to set denominator not equal to 0 and solve. And then your domain is all real numbers except whatever you got. Whenever you set that denominator not equal to 0. So I think, do we have another example? Yes, we do. I think part B. Yes. Okay, so I cut off the directions here. But the direction, this is part B. I need to find f over g. So I need to find f of x divided by g of x. I'm going to make that red. All right, so f of x is x minus 3. G of x is x squared minus x minus 6. So I'm going to simplify by factoring the numerator and denominator as much as possible. The numerator does not factor. It remains x minus 3. The denominator, however, will factor. X here, x there. If I do a minus 3 and a plus 2, it will factor. So this is f divided by g. F divided by g equals, all right, the x minus 3's do divide out. And I'm left with an x plus 2 in the denominator. And then there's nothing left in the numerator, but remember, x minus 3 divided by x minus 3 is 1. So I still need a 1 up there. So f divided by g is 1 over x plus 2. So then when I go to find my domain, remember my denominator is not allowed to be equal to 0. So this was the original denominator, but I changed the way that looked by factoring it. So I'm going to go with the middle part. I'm going to say x minus 3 times x plus 2 is not allowed to be 0. So I can solve that further by saying x minus 3 is not allowed to be 0. X plus 2 is also not allowed to be 0. Solve that. X is not allowed to be 3, or x is not allowed to be -2. Because if it is, then it will cause me to have a 0 in my denominator, and then I would divide by 0, and then I'd have an undefined expression. So my domain is all real numbers except x equals 3 and x equals -2. Now let's talk about composition. Composition is when you put one function into another function. So putting one function inside the other. So the best example in real life I can think about this is sales. So let's say you go into a store and they're having a 30% off sale, and because you're a special customer, you have a $10 off coupon. Well, for your price, maybe the store would take 30% off and then they would apply your coupon. So one function would be the result of applying 30% off. The other function would be the result of taking $10 off. That's two operations that you put in one, and it is less work to make one function instead of doing two things. So that way you don't have to grab your calculator and go 30% off is minus 10 is. Instead, you can just make one function and be like, oh, that's 30% off and $10 at the same time. So we get that through something called composition. Now the symbol for composition is an open circle, and we say this out loud. I would say that out loud as, I'm going to put some quotations, f of g of x. F of g of x. That the second part means the same thing, f of g of x. So that means I'm going to take the g function, put it inside of the f function. Maybe it's because I'm a mom and I have kids and I've been pregnant before, but here's how I think of it. F is like the mommy function, g is the baby function inside the mommy function. And like, you know, look, like the F, this is even like the little pregnant belly that mommy F has. Maybe, that may be it, why. All right, so let's look at example 4, where we're trying to find f of g of 2 for part A, and then f of g of x. So I'm going to color code these again. It really helps to do colors. F and then g. So I'm going to find f of g of 2. I'm going to figure out what that is. All right, so that means I need to start on the inside and work my way out. So I start on the inside, so that means I need to find g of 2. I'm going to come over here. What is g of 2? Well, g of 2 would be 3 times 2, because that means put 2 in for the x. Well, 3 times 2 is 6, so g of 2 is 6. So now, for my composition, I'm going to find f of, we know g of 2 is 6, so I'm going to find f of 6. Well, f of 6 means go to the f function and substitute 6 in for the x. So that equals 2 times 6, which is 12. 12 minus 1 is 11. So my answer is 11. So that means f of g of 2 is equal to 11. So you have several on your assignment where you practice that skill. The other thing that you'll have to practice is finding f of g of x. So let's practice that. F of g of x. Now they haven't given me a number to put in for x, they've just said g of x. So that means I'm going to take the g function, which is 3x, I'm going to put it inside of the x in the f function. So here's what I like to do. I like to write down the f function, because that's on the outside, 2x minus 1. But instead of x, I'm going to write parentheses, because I'm not putting in x into f. I'm putting g in place of x. So g was 3x. So this is an unsimplified version of f of g of x. F is the blue. It's what's on the outside. The g is the little baby function. It goes in place of the x. So this simplifies to be 2 times 3, which is 6x minus 1. So f of g of x is 6x minus 1. We have a couple more examples in example 5. So for part A, I'm going to color code again, f of x equals x cubed, g of x equals x plus 1. So it says find f of g and then g of x. So these notations, it looks like they're the same thing, but the order does matter. All right, so order matters. So first of all, let's find f of g, looks like fog, of x. Okay, well, I prefer the other notation, this f of g of x, because it allows me to see everything a little bit better. So you always see me rewrite it. Whatever comes first is what's on the outside. The second part is the inside part. So that means I'm going to copy down the x function, but instead of an x, I'm going to put a parentheses and cube it. And what goes inside the parentheses? Whatever that little baby is, the g function, x plus 1. Now I could cube this and multiply it out 3 times, but I'm not going to because I don't need to. This is my answer, x plus 1 to the third power. Now let's do the other one. Let's find g of f. So g of f of x means the same thing as g of f of x. This time f is on the inside. So that means I'm going to copy down the g function, x plus 1, but instead of x, I'm going to put a set of parentheses, plus 1. So it's not x plus 1, parentheses plus 1. What goes inside the parentheses? F does, x cubed. So g of f of x is x cubed plus 1. For part B, we need to do it again. So let's color code again. F of x this time is x squared plus 1. G of x is x minus 5. So let's first start off by finding f of g of x. Okay, so that means I'm going to copy down the f function, but instead of x squared, I have parentheses squared plus 1. And then what goes inside of the parentheses? The g part, the x minus 5. Now I'm only squaring this here, so you are expected to simplify this out. So that means I do need to square x minus 5, but to square x minus 5, you have to multiply it by itself and distribute. So x minus 5 times x minus 5 is x squared minus 5x minus another 5x plus 25 plus 1. So that all simplifies to be x squared minus 10x plus 26. So f of g of x simplifies to be x squared minus 10x plus 26. Now let's find g of f of x. So that means I'm going to take the g function, x minus 5, but instead of an x, I'm going to write an open set of parentheses. And what goes inside the parentheses? F goes inside the parentheses. And f is x squared plus 1. So then I'll combine like terms. Now I have x squared plus 1 minus 5, which simplifies to be x squared minus 4. So g of f is x squared minus 4. F of g, x squared minus 10x plus 26. So does the order matter? Yeah, it does, because we got 2 totally different expressions. So once again, order matters when you're doing compositions. All right, last example is example 6. It's a word problem. As a member of the Game Shop Rewards program, you get 20% discount on purchases. Underline that. It's a number. Seems to be important. All sales are subject to a 6% sales tax. Write functions to model the discount and the sales tax, then identify the rule for the composition of functions that calculate the final price you would pay at GameStop. So first of all, I need a variable. We're going to say my variable is x, and x is going to represent the price of the item. All right, so first of all, let's write a function for the discount. So my discount, to get my discount, it says I get 20% discount on the purchase. Okay, so I get 20% off. So here's how my discount works. I take the price of the item, and I'm going to subtract 20% or 0.2. Maybe I'll do 0.20. I'm going to subtract 0.20 times x, 20% of the item, which 1 minus 0.2 is 0.8. Which kind of makes sense. If you're getting 20% off, then you're paying 80% of the original price. So that's my formula for the discount. Then there's a formula for the sales tax. Sales tax is where you take the price of the item and I add, what is it, 6%? 6% of the price of that item. So x plus 0.06 is 1.06 times the price of the item. So if I went into the store and I only got the discount but not the sales price, I would use this formula. If I went into the store and didn't get the discount but only had the sales tax, then I would use this formula. The problem is I'm doing both. I'm getting the discount and then I'm having a sales tax put on. So that means that the discount happens first, and then I take the sales tax of whatever the discount was. So I'm going to have the sales of the discount of x, of the price of the item. Hey, look, that's a composition. So if I let sales tax be represented by S and discount be represented by D, I'm going to find a composition S of D of x. Okay, so once again, discount, this was D of x, and this was S of x. Okay, so S of D of x equals, let's see, the sales tax function is 1.06 times x, but I'm going to put in the discount 0.80x. Then I can simplify that. So S of D of x equals, what's 1.06 times 8? Or times 0.8? 0.848 times the price of the item. So if this applies to you, and you go into the store, and you know you get 20% off, but then they're going to charge you 6% sales tax. Instead of doing these two separate operations, you can just walk in, multiply 0.848 times any price on the price tag, and that's the price the cashier is going to tell you. Nice little trick there. But it's also math, so it's not really a trick, it's just algebra.